Hey, I'm Carsten Baas and I had the pleasure to support Pizola's Titan project with some FX work for a small shot. This is showing the actual scene from the anime Attack on Titan, in which 3 cannons are fired one after the other. So the main effect here is the expanding smoke blast with hot fire cores and some additional sparks. Let's take a look at a quick render I did before I handed over the caches to Pizola. So this is showing several FX caches. One is the main smoke blast with the additional sparks in it. I added some additional dust on the ground when the cannons are moving. I added dust on the cannons itself. It could obviously benefit from a bit more substeps here. And in addition, I added also some fuse smoke at the back of the gun barrels. This wasn't actually in the original footage I have here, but I thought it was an additional nice detail to add some smoke here at the back. So let's take a look at the actual setup. And for this shot I was provided with the different animated cannon geometries and also the shot camera. And let's dive into the actual shot work. As mentioned, I have all these different layers. I have the ground smoke, I have the dust on the cannon itself, the main blast smoke, the fuse smoke at the back, and also the additional sparks. I copied the entire setup for all these cannons. So for the Cannon B, it's basically the identical setup as for Cannon A. And for Cannon C, I just removed the ground smoke and also the fuse smoke at the back, because yeah, you wouldn't see that anyway because it's out of the frame. So let's start with the main smoke blast. I imported the geometry of the Cannon A here, isolated the gun barrel, and the first thing I wanted to do is to calculate the actual shooting direction of the smoke. So I just created a bounding box around the barrel, calculated the face area, promoted the max area to detail, and then isolated just the small faces, extracted the centroid, added a line just for visualizations. These are the endpoints with the numbers 0 and 1. I sorted them in X direction, and finally just calculated the shooting direction vector between these points. Let's check this vector. So I visualize it and scrub through the timeline. So this is looking good. And now I want to utilize this point to copy the actual source geometry onto this point, but at first I don't want to have the smoke traveling through the entire gun barrel, so I don't want to have this point at the very end of the barrel, and at this point I set here an offset in the shooting direction, in this case of 3 meters, so it's right before it exits the gun barrel. I copy the sphere on it, promoted the shooting direction vector to detail attribute so it don't get lost when I create points with the points from volume node. Before I create all these attributes required for the simulation or for the source, I want to create an additional fade attribute that is an attribute that fades over time, because I want to have the source attributes higher at the beginning of the simulation, and then it should fade slowly out. I created a custom HDA for this. You could also use the default SideFX attribute fade node. There's nothing wrong with that, but I just don't like the user interface of this node, and I also added some additional functionalities to my custom HDA. The base logic of this node is just to create a normalized frame. Like in this wrangle node, for example, I just defined the start frame and the end frame, and use the fit range node to remap the frame number between values of 0 and 1. With this you can just use this value to multiply it with the source attributes. I create here temperature, density, pressure and fuel. Here I point exactly to the value of this fade attribute. So these are the current source velocities. I added a bit, just a tiny bit of a breakup for the velocities, and finally rasterized all these attributes into volumes. So I have density, fuel, pressure, temperature and velocity source volume. At this point I just bypassed the collision object, and I will activate this in a second. All these smoke simulations were done by the Axiom solver. The main characteristics of the simulation is expanding smoke plus localized fire core. Depending on that, let's have a look at the solver and the source settings. So I have a pretty high density amount right at the beginning. I want to have a high pressure so that it expands very fast right at the beginning. I enabled combustion, of course, have the burning rate to 0.8. I want to have a little bit of density emission during the simulation, and also I cranked up the amount of emitted pressure values. So this, in this case, improved the overall expansion behavior. In the simulation tab, you find all this disturbance and turbulence settings. This is depending on the time scale, because here I animated the time scale. I want to have the push quite fast out of the gun barrel, and that then slows down soon as the most part of the smoke is outside of the barrel. So I have some additional fade attribute nodes here, one for the time scale and one additional for the turbulence. The time scale is going from 2.5, since the fade attribute here is going from 1 to 0. It will end up with a time scale of 1.5 over the whole frame range. And if you change this time scale, it should also be taken into account into all this velocity depending settings like disturbance or turbulence. Like here, as mentioned, I also multiplied one of the turbulence values with the additional fade attribute. The substeps are set to 4 and the division size is set to 0.01. Now let me activate the collision object and run the simulation. So as collision object, I have here the isolated gun barrel. Did a polyfill to close the object and just create an SDF volume named collision with filled interior that contains the entire animation. So the sim is done, and when the sim is done, you probably want to time shift or retime your entire smoke cache, but this has also to be considered in the input source and the collision object. So let me show the gun barrel in the back and jump over to the retime node I have here. I just did for a few frames a small retime, so I increased the speed at the beginnings to get a bit more aggressive push at the start. Now you will see the problem, because since I am retiming this simulation cache, it doesn't fit anymore to the original collision object's animation. This might cause some other troubles. I will show this in another example here. So this shall represent the animation curve of the collision object. The collision object in the darker green acts as a parent for the smoke source in the lighter green. So both will follow the same path in the same speed. And now I want to apply a retime to the simulation output. And this time I applied a retime with a retime scale of 4. And with this this simulation cache and the source location will run ahead and will not longer fit to the original animation of the collision, of course. To fix this, I take the reciprocal retime value and apply it to a retime node for the collision object. So it's just 1 divided by the retime scale I applied after the simulation. And with this, the input collider and the source here in dashed lines will now move with a quarter of the speed, but the source location of the retimed sim output will now match again the original collider position. So far so good, but here comes now the problem using the retime node to invert the collider animation. If the retime scale is constant, you can just use the reciprocal value to invert the retime, but this won't work anymore if the retime scale is not constant. Let's see what happens if the retime scale is variable. Here the value is animated and goes from 1 to 6 over the entire frame range. Now the animation looks like this, so it's still similar to the first example. If we now create the reciprocal value from that for the invert retime node, so it's still 1 divided by the retime scale, then the animation looks like this. You will not get back the original animation, so the animation of the input source and the collision object is still here in the dashed line. It's slower than the output. The original animation is the full circle in the dark green, but the output simulation cache after the retime node is something between, so it doesn't match to the collision object anymore. For this I created the custom retime node. Here I linked the speed to the retime scale, I activated invert retime, and after some magic I will get back the original animation. So now the retimed simulation output will match again the original collider animation. So why is this not working with the reciprocal value? This is because of the integration of the retime scale to calculate the required target frames. So for the inverted retime node, we have to remap the original and the retimed frames properly to make the retime work. And for this, let's have a look first into the default retime node. We have to look at this section here. If the evaluation mode is at 2, so it will be evaluated by speed, what we want, then this attribute wrangle will be executed. And it basically integrates your speed, or in this case your retime scale. And here the retimed frames are calculated by accumulating the time increments multiplied with the current speed, or more precise, it calculates the arithmetic mean value by considering the current and the next half time step. Then it creates for every frame in the list a point, so it can be easily read as a data table in the geometry spreadsheet. The X position is the original frame value and the Y position is the retimed frame value. So to get the related retime frame, it will compare the current frame with the X position and return the Y position. And this frame will be used in a time shift node basically to get the proper timestamp. And now I want to use this principle to get the proper original frame back from the retimed frame table. So I took this wrangle as a base for my retime node. The first node is the node that I have copied. I just modified the code so that the rounded retime frames are showing up as the Z position. These new frames will be used to create a connection between the current frame and the original animation frame. And I created some additional attributes to have also the time and the speed values in the datasheet. So in the first step, the frames are calculated from accumulated speed. It's still the Y position. But if the speed is greater than 1, you will notice that some frames will be skipped for the new frames. In the 0 frame 1008, for example, is missing. So you have to interpolate the missing frames from the existing frames. This is happening in the second wrangle node. And this node will also recreate all the previous points and add another entry for the missing frames, in this case for frame 1008, and calculates the corresponding frame value for the original animation. And with this you are able to get the relationship between the new frames and the original frames for every single frame in the C table here. And now with this you are able to invert the retimed animation. The freeze node is just here so that it don't have to calculate the list at every frame. And the Retime detail node is here to create some useful detail attributes that updates every frame. And in this Retime node, I basically point to that detail attribute to get the proper animation. Okay, I noticed that something is still not working. With the setup here, it works fine if the retime scale is greater or equal 1. But if the scale is below 1, the retime sim output will fall behind. And to test this, I animated the retime scale between a value of 0.25 and 4. So the animation will look like this. You can see that it will not match the collider animation at the beginning when the scale is less than 1. So the red circle will fall behind. Reason is that now I can have more than one entry for every lookup frame in the third column to determine the target frame for the original animation in the first column. And in the previous setup, I only checked the first entry, so this one. So for the inverted retime, I said, if the current frame is 1002, then shift my animation to frame 1003, and this is this one. So you can check it here. This is picking up this frame in this row. But I had to detect when the actual switch between the retimed frames in the second column happens. So I had to look at this point here. So what would be the original animation in the first column for a retime frame of exact 1002? And this is calculated in the additional wrangle node here. And the original frames will be replaced by that interpolated frame. So this was the first column before, and this is the recalculated interpolated original animation frames. And now if I check the animation, you can see that the red circle will have again the same animation as the green circle. And just one thing to mention, since this is still a linear approximation, you can have some larger deviations to the original animation. If you decide to go for very small retime scales and do an inversion of that, since you will lose some information of the original animation. I applied the retime node right after the simulation. The retime scale is an animated value between 1 and 3. So it starts with a value of 1, then it fades in to the maximum value in 2 frames, it holds the maximum value for 3 frames, and then after another 4 frames it will fall back to a value of 1 again. In addition, I also have a time shift here, because I wanted to shift the whole simulation by a couple of frames. For this I changed the interface of the time shift node and saved it as a preset here. I have 2 additional parameters, a toggle for reversing the shift and an integer parameter to give the start frame when the simulation actually should start. So I gave a frame number of 1004. This parameter will be read here. This is the start frame minus the start of the frame range, so it will add 3 frames to the current frame. And this power function here is for the toggle to reverse the shift. So if I have this toggle off, then this value is 0 and minus 1 to the power of 0 is 1. So it will add 3 frames. I'm currently at a frame 1011 and here it shows 1014. If I enable this toggle, then I have a frame of 1008, because then it will just subtract the 3 frames. And for the input source and for the input collider, I'm doing exactly the opposite. At first I am applying the time shift node with the time shift in the opposite direction, and after that I'm applying the retime node with the invert retime activated, and I'm doing the same for the collision object here. At this point I cached everything to disk, so let's have a look at the final simulation. So it looks like this. I use a pyrobake volume to visualize the flame field. For all my caches I'm using a custom caching node, since this will take care of my preferred version management. The cache version is always set according to the version of the hip file. In this way there is a clear connection between the cache and the hip file, and you can always reproduce older versions. If you want to version up your entire hip file, you can do that here. You can archive old hip files. This is for setting up the naming convention for the versioning. You can define the file type you want to cache, some topnet settings, you can add pre-roll. You have the ability to import project caches from other hip files in your project. So you can select the hip files, select the caches from these hip files and select the versions. Here you have some optimization settings before you're caching out, some post-process, topnet settings. Here I define the location of the dependency networks. I can use RobNet or TopNet for that. And I have some a section for the pre and post render scripts. And for the Axiom solver I added an additional option. So you have the ability to specify your solver node here. You can just drag and drop your Axiom solver into this field. And what this is doing, it adds a pre-render script and a post-render script. So if you want to cache something out, then it will at first activate the Axiom solver node. Then after your cache has finished, then it will disable this node again. And this way I make sure that only one solver node at a time is activated. And another cool thing is if you want to create a dependency tree in RobNet or TopNet, let's say I want to use TopNet, then you can just hit this button and it will create the appropriate labs file cache for you. And it will also connect everything to the previous cache node. It will also place a submitter node, and if you press the submit button, then it will start cooking. And it also updates all versions for the caching nodes you have at sub level. All these custom HDAs that I used in this shot will also be available for you. I will upload it to my Gumroad page as well as this hip file. So the whole package is for free to download, so feel free to download it and use it in your own project. And now let's get back to the setup. For the sparks I scattered some points onto a sphere with the position of the locator using the same position offset as for the smoke. I used the fade attribute to remove the points over time. For this I have this toggle here. The velocity has the shooting direction and is also driven by the fade attribute. And the magnitude of the velocity is randomized by multiplying a random value between 0.2 and 1. Then added some additional breakup to the velocities. The .NET setup is just as simple as the source setup. I'm getting here my scattered points. I'm adding a little bit of drag to it. To have an influence of the smoke sim onto the particles, I'm getting here the velocity field of the smoke sim. So this object merge is pointing to this node here that is getting the isolated velocity field. But I want to have a different impact of the velocity field. So I'm using Vex here to set a unique randomized blend value. This value will override whatever you have in this parameter here. Then I'm using a gravity, -4. I'm using a simple ground plane as a collision object. And this is how the simulation looks like. I removed most of the attributes I don't need. For rendering I added a randomized p-scale. I trailed the particles for some fake motion blur shapes. Another approach would be to just render with motion blur using the particles as they are, or meshes instant to that particles. Connected the points, increased resolution, then added anti-aliased flow noise to make the shapes more interesting. Added some color. For more emissive feeling, increased the color values, made a final tweak for the timing, and finally cached to disk. The setup for the view smoke is even simpler. Here I used a simple Axiom source shape positioned with the locator without any offset. Like always, I'm using a fade attribute to control the source values. Here I am animating all source attributes equally. I'm using a force in y direction so that the smoke gets pushed upwards, and I added a velocity noise for breakup. This goes into the Axiom solver. This time it is the right input because it is an Axiom proxy shape. The source settings are similar to the main smoke sim, but here the focus is more on density and velocity and less on expansion. This time I'm using a constant time scale, so the disturbance and turbulence values are not depending on the time scale. I have no combustion and I only need density and velocity fields as output. After the sim I applied the same retime and time shift as I did for the main smoke. For the dust on the cannon I scattered a lot of points on the entire static geometry and applied the animation later after scattering and applying the density noise. So the noise here will move with the animation. For this you have to enable the prim and prim UV attribute when scattering the points. The UV attribute defines the exact position of the scattered points on the primitives of the base geometry, and these attributes will be used in the attribute interpolate node to interpolate the current position of the scattered points on the animated target geometry. In addition, I masked the density values with a height ramp so that I have a fall-off in the y-axis. And another advantage of this setup is that I'm able to calculate velocities of the points without having an ID attribute, since the point count and the original scatter position will not change. I'm using the velocity to trail back the points randomly. So here I create a random value from the point number, multiplied it with the velocity and subtract this from the position. For an exact blend between frames, you have to divide it by the frames per second. So here it is 24. And I used an additional multiplier to control how much I want to have the trail effect. Reason for this is to reduce the substepping artifacts in the sim output and therefore to reduce the amount of required substeps. And here I'm driving the density also by the speed. I want to push the smoke a bit outwards to the geometry. I'm adding velocity breakup and rasterize the volumes. And these are my solver settings, so nothing special here. And this is the outcome of this simulation. Let's have a look at the ground dust caused by the moving wheels. For this I isolated the rim of the wheels and extracted the centroids. Since I only want to emit some dust when the wheel is moving, I calculated the speed, promoted this to detail attribute and used this later as a density mask. I brought the points to the ground by scaling the y-axis to 0, added an ID attribute for both points. And here I merged the start position with the current position of the points, transferred the speed attribute, and created polylines for the path by connecting the points from the start and the current state. I'm setting here the normal attribute to the direction I want to extrude the line and applied a poly extrude using the normals in the local coordinate system to have a width of 0.25. I brought them back to the center by offsetting it by half of the width, cleaned attributes, and created a solid to have some geometry in which I can scatter points using the points from volume node. The velocity here is pointing in the up and a bit in the shooting direction, and I also added some breakup. The density values on the points are depending on the distance from the extracted centroids I created first. Here I'm using a fit range I can control with the max radius, how far the density mask extends. And in the second line I'm using another fit range to control the influence of the speed. The velocity is multiplied here with the same mask values as the density. This is visualizing the density values, so it is increasing with the speed of the wheels. Then I lifted everything a bit up, adjusted the starting frame, and finally created the source from it. The source goes into the first input of the solver. In the second input I'm using here an Axiom proxy shape to introduce a force in the same direction as the source velocity, and I'm also multiplying here the max density value. A second Axiom shape defines a ground collider using a plane shape. At this point I noticed something strange when I tried to simulate it, because it was sourcing nothing at first. That happened when the source layer was too thin. I have an example here. I extruded a grid to get a thin geometry, created a lot of source points, created my source attributes, set a height for the source, rasterized it to volumes, so the source here is fine, and now I just start a simulation. And as you can see, nothing is happening. If I now change the height of the source, you will see that the sourcing will maybe work, maybe not. To fix this, I customized a bit my Axiom node, so I created a bounding box for my source and used that as an Axiom pump source. I'm not sure why this is called pump in this case, but what this is doing is it pre-activates the entire simulation field defined by this bounding box, so that the activation does not have to rely on the smoke source itself. And this way I make sure that my sourcing will always work. I created a toggle for this, which I personally want to have enabled per default to avoid this issue. For this shot I was using Axiom 3.1.096, and if you experience the same issues, then now you will know how to fix it. Like for the other caches, I was adjusting the timing with a retime and a timeshift node. And now let's also have a quick look at the final ground smoke for this cannon. So nice and simple. As mentioned, I had just copied all the setups for the other cannons. For the final export I was using Prism file cache node, since my file path on disk and metadata had to match Pizola's pipeline, since Pizola is using Prism as his main pipeline tool. If you want to have a look how I had set up the shaders for my quick whip render, you can switch to Solaris stage and just investigate my setup there. But this should be it for now. Alright,